My name is Amr Schalberg, and this is the second video on a series on assembly programming. In this video, we're going to cover how to convert decimal to binary. So now that we can go from binary to decimal, let's practice going from decimal to binary. Now you may notice that we run into a scaling issue here. So for example, if we have 5 in decimal, how do we get that in binary, right? Well, we could look at this as we have our ones column here, our twos column here, and our fours column here. So here we would need 1, 1, so 1, 0 twos, let's say 0, a full 0, and we would need 1, 4. So we would need 101. But what do you do if this is 5,647? This method becomes inefficient very quickly. So instead what you can do is take your decimal number, your more complex decimal number, let's, 1,863. And we're in a base 2, right? So what we want to do, and I'll be busting out the calculator for this one, is divide this number by 2 until the quotient is 0. Very quickly, here are the rules for converting a decimal to a binary number. While the quotient of the number is greater than 0, we will divide it by 2. We will then add a 1 to the binary output if there's a remainder, else we're going to add a 0. And we'll throw out the remainder of the number that we divided. And then we will repeat this until the quotient is 0. And every time we do that, we want to mark down if there's a remainder of 1, we want to add 1 to our binary number. And if there's no remainder, we want to add a 0. So I'll just erase this and we will start. So 1863 divided by 2 is 931. 63 divided by 2 is 931.5, so we have a remainder of 1. So we will add, we'll do this over here, so we've got space, so 1. Now we're going to kick off the remainder, so we will have 931, and we'll go ahead and divide that by 2. We will get 465.5. So we have another remainder. So we'll go ahead and add our remainder. 465 divided by 2 is 232.5. So we have another remainder. And we'll have 232. And we'll go ahead and divide that by 2. Of course, this is even, so this won't have a remainder. We get 116. So 116. And because we didn't have a remainder, we'll go ahead and add a 0. Divide that by 2. And we'll get 58. And we didn't have a remainder, so we will add a 0. And I appear to have spaced poorly here, so we're going to go back down here. 58 divided by 2 is 29. And because we didn't have a remainder, we'll go ahead and throw in our 0. So 29 divided by 2 is 14.5. So 14. And we'll throw our remainder down here. Divided by 2 is 7. No remainder. 7 divided by 2 is 3.5. So we have a remainder. 3 divided by 2 is 1.5, so we have a remainder. And so we have 1 divided by 2 is 0.52, so we have a remainder. And then we throw out the remainder, so 0 divided by 2, we are done. This is 1863 in binary. Now, to prove that to ourselves, we can, let me get rid of happening here. Actually, okay, let me write this up here. So we have 1, 1, 1, 0, 1, 3 zeros, and then 3 more ones. Get rid of this one down here. All right, so we have our ones column. We have our 2s, 4s, 8s, 16s, 32s, 64s, 1, 28, 256. I'll write this down here. 5, 12, and finally our 1024. So starting from left to right, we have 1024 plus 512, which is 1536. With our next position, 256, which is 1792, plus our next position, which is 64, so plus 64, and we have 1856, right? Yes. Plus 4 plus 2 plus 1, so 1856 plus 7 equals 1863. So now that we know the algorithm to convert decimal to binary, let's practice it. So first, let's start with 163 decimal. So 163 divided by 2 is 81.5. So divided by 2 equals 81.5. So we'll go right here and we will throw a 1 into our binary number. So we'll throw out the remainder. And we will divide that by 2. So 81 divided by 2 is 40.5. So we had a remainder, so we will add 1 here. And we'll ditch it again. Next, we'll divide 40 by 2, and we'll get 20. And we didn't have a remainder, so we'll have a 0 here. We'll divide 20 by 2 again, and get 10, so no remainder. And 0. And 10 divided by 2 is 5, no remainder, so we will add a 0. 5 divided by 2 is 2.5, so we have a remainder. And this equals 2.2.5. I do apologize for my handwriting. Now we will get rid of that remainder. And 2 divided by 2 is 1. There is no remainder. And 1 divided by 2 equals 0.5, so there is a remainder. And of course, now we're going to throw out the remainder. So our quotient is now 0. And this is our answer. Let me outline that in a different color, actually. This is our answer. All right, next let's do 59. I'm going to move this over, give myself a little bit more space than I've been doing. So 59, we'll change that back to the right color. 59 divided by 2. Just double check myself here. 29.5. So our number will have a 1, and we will dismiss the remainder. 29 divided by 2 is 14.5. Let me see. Yep, 14.5. So we will add a 1 here as there is a remainder. Go ahead and dismiss that. 14 divided by 2 is 7. No remainder. 7 divided by 2 is 3.5. And so we have a remainder. We'll go ahead and dismiss it. Throw it out. And 3 divided by 2 equals 1.5. So we have a remainder. We'll get rid of the remainder. 1 divided by 2 equals 0.5, and we have a remainder. And now we no longer have a non-zero quotient. So it should be a full 0. And so our answer is 111011. All right, now let's knock out the final number, 28. Let me use the right color here. Okay, so 28 divided by 2 equals 14. So our number will start with a 0. And 14 divided by 2 equals 7, so no remainder. So we have a 0. You'll notice that the only even number that we've done here, we've done 163, 59, 28. We also did, I think it was 1863 for the primary example. The only even one out of these, the first digit, the rightmost digit is a 0. And that's very important in binary because everything else is a multiple of 2. So the only way to have an odd number is for that first column to the right to be a 1 because it is a multiple of itself. Everything else, if it was in the second column, 1 would be a 2. If it was in the third column, a 1 would be a 4. So all the odd numbers are going to have a 1 in this rightmost column, and the even numbers are going to have a 0. So we divide by 7 by 2, and we'll get 3.5. 0.5. We have a remainder, so we'll put 1. Kicking the remainder away, we will have 3 divided by 2, or 1.5. And so we have a remainder, and so we'll throw out the remainder. Wasn't very clean. So 1 divided by 2 is 0.5, so we'll throw in a 1. And because that is a remainder in and of itself, we no longer have a non-zero quotient. And we are done. Our answer is 11100. In this video, we covered how to convert decimal to binary and how to use the divide by 2 method to make it more efficient. In the next video, we're going to cover why computers use hexadecimal and how to convert between binary and hexadecimal numbers. I hope you found this helpful.